Hi everyone, in this video I am going to explain about the digital voltmeter. We will learn its working principle and how it accurately measures the AC and DC unknown voltage. This is an important topic for the students of EEE as well as those who are preparing for a competitive exam. If you find this video helpful, please like, share and subscribe to my channel for more education content. Let's get started. Digital voltmeter. The digital voltmeter are generally referred as DVM, convert the analog signals into digital and display the voltages to be measured as discrete numericals instead of the pointed deflection on the digital display. Such voltmeter can be used to measure AC-DC voltages, and it is also used to measure the quantities like pressure, temperature, stress, etc. using proper transducer and signal conditioning circuit. The transducer converts the quantity into the proportional voltage signal and signal conditioning circuit the signal into proper limits which can be easily measured by a digital voltmeter. The output voltage is displayed on the digital display on the front panel. Such a digital output reduces the human reading and interpolation error and parallax error. The DVM have various features and the advantage over the conventional analog voltmeter, having pointed deflection on a continuous scale. There are many advantages of digital voltmeter. These are: due to the digital display, the human reading error, interpolation error and parallax errors are reduced. They have input range from 1 volt to 1000 volt with the automatic range selections and the overload indication. The accuracy is very high, up to 0.005% of the reading. The resolution is very better. The input impedance is high as 10 mega ohm. The reading speed is very high due to the digital display. They can be programmed and well suited for the computerized control. The output in digital form can be directly recorded and it is suitable for further processing also. With the development of IC chips, the cost of DVM, size and power requirements of DVM are reduced more. Due to small size, they are portable. The internal calibration does not depend upon the measuring circuit. Every ADC requires a reference. The reference is generally internally, and reference generator circuitry depends upon the type of ADC technique used. The output of analog to digital converter is decoded and the signal is processed in the decoding stage. Such a decoding is necessary to drive the 7-segment display. The data from decoder is then transmitted to the display. The data transmission element may be counter or etc. As per the requirement, a digital display shows the necessary digital result of the measurement. Classification of the digital voltmeter. The digital voltmeter are classified mainly based upon the technique used for the analog to digital conversion. Depending upon this, the digital voltmeter are mainly classified as integrating type and non-integrating type. The non-integrating type digital voltmeter are further classified as potentiometric type, servo potentiometric type and successive approximation type. And the second type is ramp type. They are subclassified as linear type and staircase type. The integrating type digital voltmeters are voltage to frequency converter, potentiometric type and dual slope integrating type. Successive approximation type DVM. It is a non-integrating type DVM. The potentiometer used in the servo balancing type DVM is linear divider, but in successive approximation type of digital divider is used. The digital divider is nothing but the digital to analog converter. The servometer is replaced by a logic electronic. The basic principle of measurement by this method is similar to the simple example of determination of weight of the object. The weight is placed at one side of the balance and the approximate weight is placed on the other side. If the weight placed is more, the weight is removed and smaller weight is placed. If the weight is smaller than the object, another small weight is added to the weight present. If now the total weight is higher than the object, the added weight is removed and smaller weight is added. Thus by such successive procedure of adding and removing, the weight of the object is determined. The successive approximation type DVM exactly works on the same principle. In successive approximation type DVM, the comparator compares the output of digital to analog converter with the unknown voltage. Accordingly, the comparator provides logic high or low signals. The digital to analog converter successively generates the set pattern of signals. The procedure continues till the output of the digital analog converter becomes equal to the unknown voltage. The capacitor is connected as the input of the comparator. The output of the digital to analog converter is compared with the unknown voltage by the comparator. The output of the comparator is given to the logic control and sequencer. This unit generates the sequence of code which is applied to digital to analog converter. The position 2 of the switch S1 receives the output from digital to analog converter. The unknown voltage S1 available at the position 1 of the switch S1. The logic control also drives the clock which is used to alter the switch 1 between the position 1 and 2 as per the requirements. Consider the voltage to be measured is 3.7924 volt. The set pattern of the digital to analog converter is say 8421. At the start, the converter generates 8 volt and the switch at the position 2, the comparator compares the unknown voltage. The capacitor C charges to 8 volt. The clock is used to change the switch position. So during next time interval, the switch position is 1 and the output input is applied to the capacitor. As capacitor is charged to 8 volt, which is more than the input voltage 3.7924 volt, the comparator sends high signal to the logic control and sequencer circuit. This high signal resets the digital to analog converter, which generates its next step of 4 volt. The generator again generates high signal. The again resets the converter to generate the next step of 2 volt. Now 2 volt is less than the input voltage. The comparator generates low signal and sends it to logic control and sequencer circuit. During the generation of low signal, the generated signal by the converter is retained. Thus the 2 volt step gets stored in the converter. In addition to this, the next step of 1 volt is generated. Thus the total voltage level becomes stored 2 plus generated 1, therefore 3 volt. This is again less than the input and generated low signal. Due to low signal, this gets stored. After this, 0.8 volt step is generated for the second digit approximation. Thus the process of successive approximation continues till the converter generates 3.7924 volt. This voltage is then displayed on the digital display. At each low signal, there is a incremental change in the output of the digital to analog converter. Thus the output voltage approaches the value of the unknown voltage. The limit to how close this input can approach the unknown voltage depends upon the level of noise at the input of comparator and the stability of the input switch. To reduce the noise, filters may be used, but it reduces the speed of measurement. These limiting factors usually determine the number of digits of resolution in an instrument. The general range of digits is 3 to 5. The speed depends upon the type of switches used in digital to analog converter and comparator. If solid state switches are used, the high speed can be obtained. Advantage. The advantage of successive approximation type DVM are it is very high speed of the order 100 readings per second possible. The method of ADC is inexpensive. The resolution up to 5 significant digits is possible. The accuracy is very high. The disadvantage of successive approximation type DVM are the circuit is complex. The DAC is also required. The input impedance is variable. The noise can cause error due to incorrect decision made by comparator.